Hello, and welcome to the OutSystems YouTube channel. My name is Rodrigo, and today I'm going to be talking about Model Context Protocol. MCP is an open standard defined by Anthropic that allows large language models to contact external systems. Think of it as an API for AI to talk to the outer world. This is becoming a de facto standard, and that's why it's important we take a look at it. MCP provides three core capabilities: tools, resources, and prompts. Today, we'll be using OpenAPI that at this point only supports tools, so we're going to focus on that. The way this all comes together is by first having an MCP server identified by a URL. Your application, when contacting the large language model, will tell it which MCP servers it's allowed to use. The model will then ask the MCP server what is available, and the MCP server will return with the list of tools, prompts, and resources. Based on that, the LLM will decide which tools it needs to use in order to reply to the query from the user. Once the model is able to complete the answer, it will send the results back to your application, including all the tools that were used in the process. It's time to dive into the code and see MCP in action. We start by creating a Python environment and activating it. We then can install the packages. We're going to use FastMCP to quickly create an MCP server and requests to make API calls to OpenAI. We open Visual Studio Code and we can import the FastMCP package. For the database, we're going to create a static list of Pokemons, Bulbasaur and Charizard. These two will get us started. We can then create an instance of FastMCP called Pokédex. You need to set stateless HTTP to true. The host and the port don't matter. We are now going to create a tool. This tool is going to list all Pokemons, and the only thing it needs to do is print out something so we know it's executing and return the list. Actually, we don't want to return the full list. We want to return an element that has a list, and that will only return the ID and the name of the Pokemons, so that we don't have too much info on the list. We also need to put some documentation so that AI knows exactly what this tool does and when to use it. We can also help it by defining the types that will be returned by this tool. This uses the typing conventions of Python. The next thing we want to do is create another tool that will give us the details of a Pokemon. So this will take an argument, ID of the Pokemon, and again, we're going to define the output to help AI make the right choices. We also put the description for the same reason, and we're going to print just so we know what's going on. And here we are going to create a list with all the Pokemons that have an ID and just return the first one. Of course, if you want to be careful, you can also check if the Pokemon really exists and leave an error message if it doesn't. Next, you just need to define the main function that will be in charge of running the MCP server with the transport streamable HTTP. You save the file and now you can start testing. So you launch your MCP server with Python, and in order to test, I'm going to use MCP Inspector. This is a tool that you can just execute with npx, and it will launch a web browser that will connect to your server. Before you go on, you need to configure the proxy token. So you just copy paste it from the command line, and you need to make sure that you have the proper URL. In this case, it was already there, so I've connected, and now I can list my tools and even execute the tools to make sure everything is working. So I have the list of Pokemons, and I can also test the get details by choosing an ID. If I put an ID that's not there, it will return that the Pokemon was not found as expected. With the MCP server done, now it's time to create our access to OpenAI. So I'm going to use .env to load configurations. I'll also need to access the package of requests in JSON. And I start by loading all the configurations that include the API key and setting the URL that I want to call. You can see that I'm using the responses API from OpenAI. For the headers, I need to set the content type and the authorization token that I got from my configuration file. Next, I'm going to write the body, and this is where I'm going to choose the model that I want to use, and I'm also going to configure the MCP server that I want to use. But notice that I need the URL accessible to the internet. And for that, I'm going to use ngrok to make sure that this is available from the outside. I copy the generated URL to the body, and I can now define the prompt. So I want to create a report on Bulbasaur and Charizard and include the results of a potential battle between the two. Next, just call the request post with the right URL headers and body, and I'm just going to print the JSON. We save the file, and of course, we need to create the environment file with all the configurations. I'm not going to put them here because they're secret. You need to put some actual values. To make sure that this works, we're just going to activate our environment and call the Pokemon report. We wait for a bit for the result of OpenAI, and you can see that we have a big JSON that includes a call to list the tools, a call to list the Pokemons, and the results of our battle. Now, of course, this is very ugly, so we can make it a bit prettier. And for that, I'm going to create a few handlers for the type of message that come in the JSON. We'll have a handler for message, MCP call, MCP list tool, and then we'll just need to iterate the output and do the fine print. We call the tool again with this improved output, and it will return a markdown. We can just copy paste all of this markdown and put it in a markdown editor to see the final result. You can see that we have here a report that tells us exactly what AI did in terms of listing the Pokemons and getting the details, and it has all the information about Bulbasaur and Charizard. By the way, I noticed that I gave the wrong name to the file, so let's fix that. This was fun, but we can do better. Let's take it one step further and connect our MCP server to an actual application, and let's have OpenAI perform an action for us. Just like before, we'll have our application, OpenAI, and MCP, but now we'll add an application built in OutSystems called Pokédex. The communication between application OpenAI and MCP stays the same, but now when we ask things to MCP, it will contact the Pokédex to fetch the list of Pokémons, to get the details of a Pokémon, and to store information about the battle. With all this data, OpenAI can now give the best answer to our application. Let's see how it works. So here's an application I did earlier that has a list of Pokemons. You can see it has several pages of these cute little creatures, and it also has a register of the battles they perform against each other and who's the winner. This was done using OutSystems, and what I did was I exposed some APIs, some REST APIs, so that you can access the Pokemon details, that you can access the Pokemon list, and also that you can register battles between two Pokemons. With this, we can start tweaking our MCP server. So I'm going to use .env to get the parameters from my server. And with that, I'm going to get the host. I can delete this Pokemon list that I had before, and now I'm going to get it from a REST API from my application. I'm going to return the JSON from that, and if the status code is different than 200, I'm going to say I could not retrieve. So just a small check. Now, of course, the type is going to change. That's why we have the red squiggly line. So we need to adjust the return to account for that. We then do something similar for the details where we get the information from our server and return the response or not found if we cannot find it. We're going to create another tool. This one will register the results of the battles between Pokemon. We need to put documentation so the AI know what's going on, and we're going to print some debugging information. This will just call a post from our server registering the information of who's the winner and who's the loser. As always, we set the data types to help the LLM. We can now go back to the Pokemon report and use these capabilities. But first, let's adjust the prompt. I'm going to split it into a user prompt where I have the question and a system prompt where I'll set up some instructions and some guidance to the LLM. I'm going also to change my prompt to include the fact that I want to record the result of the battle. So now I'm ready to test this. I go back to my command prompt, I restart the MCP server to make sure it has the latest version, and I can now run my Pokemon report. If I go back to my MCP server, I can actually see what's going on. And it's getting the list of all Pokemons, it's getting Pokemon ID number 1, it's getting Pokemon ID number 6, and actually it's starting to get again the details for the Pokemon. This isn't a very good sign, and things didn't go as expected. Fortunately, we have the MCP inspector to guide us on what's going on. So we launch it, we check out what's going on in terms of getting Pokemon details. I'm going to run the tool and we can see there's an error. I actually forgot that the data type returned from the details has changed. We can now also have float values. So I'm going to update the code. I will restart the MCP server to have the latest version running. I will go back to my MCP tester and make sure everything is all right. It's important that you reconnect and refresh the tools to test this out. And now when I run it, I can see that everything is working as expected. So back to our command line, we can get rid of the inspector and retry the call to our LLM. And now we can see that it's getting Pokemon number 1, it's getting Pokemon number 6, and it called the recording battle. So it has registered what has happened. If I go back to my command line, it's still processing. Here it is. We have the result in Markdown. So I'm going to copy paste this again to my Markdown editor so that we can see it as a pretty input. And you can see it got the Pokemon details and it recorded the battle. The battle is of course also available in the OutSystems application we built earlier. The example we did here was a very simple application. If you have something a bit more complex, I would recommend you'd go low-code to build it and have it running in production. If you want to see more of OutSystems and MCP in action, just follow the link on this video. Thank you so much for watching and see you again soon.